my dear students. Today I am going to talk about solar energy systems. Okay, part 3. ലാസ്റ്റ് ക്ലാസ്സിൽ ഞാൻ എടുത്തിട്ടുണ്ട് എന്തൊക്കെയാണ് സോളാർ എനർജി സിസ്റ്റം ഫസ്റ്റ് പാർട്ടും സെക്കൻഡ് പാർട്ടും. ഇന്ന് എടുക്കാൻ പോകുന്നത് വന്നിട്ട് മൂന്നാമത്തെ പാർട്ടാണ്. ഇന്ന് ഡിസ്കസ് ചെയ്യാൻ പോകുന്നത് വന്നിട്ട് വർക്കിംഗ് പ്രിൻസിപ്പിൾ ഓഫ് സോളാർ സെൽ ഡിവൈസ് സ്ട്രക്ചർ, ടൈപ്സ് ഓഫ് സോളാർ സെൽ കൺസ്ട്രക്ഷൻ. ഓക്കെ, അപ്പോൾ നിങ്ങൾക്ക് എൻ്റെ ക്ലാസ് ഇഷ്ടപ്പെട്ട ലൈക്ക് ചെയ്യുക, സബ്സ്ക്രൈബ് ചെയ്യുക, ഷെയർ ചെയ്യുക. സബ്സ്ക്രൈബ് ചെയ്യുമ്പോൾ തൊട്ടടുത്ത് ബെൽ ബട്ടൺ കൂടെ ക്ലിക്ക് ചെയ്താൽ ബെൽ ബട്ടൺ ഓൺ കൂടെ ക്ലിക്ക് ചെയ്താൽ ഞാൻ ഇടുന്ന എല്ലാ വീഡിയോസും നിങ്ങൾക്ക് നോട്ടിഫിക്കേഷൻ ആയിട്ട് കിട്ടുന്നതാണ്. ഓക്കെ, നമുക്ക് നേരെ വീഡിയോയിലോട്ട് പോകാം. Working principle of solar cell. Working principle of solar cell, PN junction diode. Okay, the picture shows a PN junction diode. Okay, when the sunlight falls through the PN junction diode, there will be a depletion region. Okay, at that depletion region, the electrons will flow at that much region, and holes will flow that much region. Means at that red side is holes and the blue side is electrons. Okay. The voltage will flows means that electrons will flows through the hole side, then n dot means that negative side, then electric current is flows. Okay, holes will flows through the opposite side. Okay, when we bring p-type and n-type material together, diffusion occurs on the surface between them. Electron starts to diffuse from n-type and p-type. Similarly, holes will diffuse from p-type region to n-type region. This diffusion creates electron hole free region is in a very short distance at the interference region. This thin layer is called depletion region. Okay, working principle of solar cell. The right side picture shows a symptomatic diagram of how solar cell works. Okay, the solar radiation from the sun strikes the solar cell. Okay, at that time it consists of a glass lens to protect the solar cell. Okay, then the sunlight strikes the solar cell in the depletion layer. At the depletion layer, the photon. Okay, I will show just a picture so that you can understand very clearly. This is a picture. Okay, when the photon means light falls through the atom, okay, of the silicon. Okay, at that time an electron hole will be separated. Okay, electron separated from the hole. Okay, this will occur. Okay, this will occur here. Then the electric currents will pass through the conducting strips. Then electrons will flow through the voltmeter. We will get a variation. Then that holes, okay, will pass through the p-type region. Okay, this is how the working of the solar cell. Okay, solar cell is considered as a major candidate of for obtaining energy from sun, as it can convert sunlight directly to electricity with high conversion electricity. Okay, it can provide nearly permanent power at low operating cost and is almost free of pollution. Okay, in the right side it shows a simple picture of a PV cell system. Okay, it is like diode. Okay, then next is the solar device structure. Solar cells are mainly formed by creating p-n junctions region. Okay, in the semiconductors. The picture shows a cross-sectional schematic and typical solar cell. Okay, when the solar radiation passes through the depletion layer, an electron hole will be produced. Okay, electrons will produce electricity and holes will be in the reverse direction. Okay, first it will have an anti-reflection coating, because if the sun rays reaches the cell, it will get damaged. Okay, so anti-reflection coating is coated. Then an emitter. Okay, then it consists of a base and rear contact. Okay, next is the solar device structure continuation. The first layer is called emitter layer, which is usually more heavy doped and thinner than the base layer. Base layer is thickly and lightly doped, and most of light absorption happens in this layer. Lower doping causes high minority. 1 minute. Okay. Minority carrier lifetime and higher diffusion coefficient, which in turns improves the carrier diffusion length. Lower doping in the base increases the depletion region in the base, which can aid the carrier collection due to the electric field. If the doping is too low, it may increase the dark current, which may degrade the performance, because the temperature, when the temperature is very high, at that time it will the efficiency will be reduced. Okay. Types of solar cell. Okay, there will be three types of solar cell. First is monocrystalline silicon solar cell, polycrystalline solar cell, and third one is amorphous silicon solar cell. Okay, these three solar cells are very important because nowadays monocrystalline structure is not used. Amorphous silicon solar cell is used, which is very delicate and very important, and if we use amorphous structure, it will get damaged very soon. Okay, for that we have to be very careful using. Okay, sorry, we should care the amorphous silicon solar cell very carefully. Okay. Monocrystalline solar cell is Monocrystalline solar cell is also called single crystalline solar cell. It is constructed to be made from a very pure type of silicon. The silicon cells are very finely packed like solid. Okay. Then next one is polycrystalline solar cell. Polycrystalline solar cell is called as polycrystalline or multicrystalline cells. Okay, because it is just like water. Okay, we will study in the smaller classes solid, liquid, gas. Okay, at that time liquids will be very flexible than solid. Solid will be very highly packed. Okay, in liquid structure is like polycrystalline solar cell, so it consists of multi silicon cells. Okay, amorphous crystalline solar cell is amorphous crystalline solar cell belong to the category of silicon thin film. The word amorphous literally means shapeless. The silicon cell is not constructed or crystalline or on a molecular level as many other types of silicon based solar cell are. It is made up of layered voltaic material deposit onto the surface. Okay. Next is a solar cell construction. Okay, it consists of a solar PV cell. The solar PV cell, several solar PV cell will form the solar cell. Okay. Uh, First, it consists of a frame, then a glass cover to protect the solar cell, then it consists of polymer sheet, then solar cell, then we have the backing system to protect on the back side also. Okay. Next is cell means a single solar cell, diode. Okay. Then module means a several cells forms a module. It is connected in series. Then several module, okay, will form an array or panel. The appealing characteristics is consumes no fuel, no pollution, wide power handling capabilities. Solar power helps to stop global warming. Solar power saves money. Advantages are environmentally friendly, no noise, no moving parts, no emissions, no use of fuel and water, minimal maintenance requirements, long lifetime up to 30 years. Electricity is generated whenever there is light. Solar or artificial PV operators even in cloudy weather condition. Modular custom made energy can be sized for any application from watch multi megawatt power plant. Okay. Next is the solar panel working. Okay. When the solar radiation falls on the solar panel, it will produce a DC current because solar cell is a react like a battery when it falls on the solar radiation falls on the cell. Okay, then it will convert the DC current to AC current by an inverter. Okay, then the current will flows through the electricity and will get the home like light, fan, fridge, AC, like that. Okay, then after that we will get extra current. Okay, that will be we will credit it to the grid. Okay, this I already explained what is the solar cell working principle. Okay, next class I am going to discuss about choppers, inverters, battery, and charge regulator. Okay, thank you and all the best for exams. Study well.